So nice to meet you. My name is Sharon. Thank you for being here. I'm a part of the Blue team that organized this day. I want to thank you for taking your time and coming. So first of all, I want to say that humanity has been dependent on the ocean for a lot of years. It's been there for food, it's been there for exploration and trade, and this dependence is evolving. We can see now that undersea cables for communication, energy, and also desalination factories are rising, and this evolution creates new challenges, weaknesses, and opportunities. We have two experts here. Each of them has a different experience. I want to introduce them and then give them the stage for a talk. By the way, I misplaced my cards. My daughter forbidden me from using my phone. I wonder where she got that, as it's not polite. So this is why I'm using papers. So we have here Dr. Gil Young. He's a naval architect, one of the few we have in Israel, and also marine engineer. He's currently the Chief Science and Technology Officer of the Israeli Coastal and Marine Engineering Research Institute, CAMERI. He's heading the innovation and the research part there. Gil started his professional career as a super yacht designer. He designed for almost a decade. He led a team of designers in Holland, right? In the Netherlands. After that, he pursued his PhD and also his postdoc in environmental engineering in the Technion. He's an expert in floating solutions and sustainable urban development offshore. Thank you, Gil, for joining us. Also, we have my friend Oren. He's assistant professor. He's heading the Swarm and AI lab, and he will present for us a bit of the technology and will share some of the challenges and the future to come. Oren, thank you for being here. So before we start, I just wanted to share with you a few insights or a few interesting things that I've encountered in the last few weeks. This headline, Digital Drought Fix. The UK government apparently recommended its citizens that in order to conserve water, save water, they requested from them to delete emails and also pictures in order to save space and make data centers work less. This is the first time I see a recommendation of saving water that comes in the digital realm and not closing the tap or fixing the pipe. Sorry. Another fact is the rise of AI. We are dealing with AI today, maritime AI. Apparently, we also see it in the center, the amount of startups that are using maritime AI. So apparently, between 2023 and 2024, the market has tripled, and as we see, it's going to be even bigger. Another interesting headline that I saw was regarding fishing. We saw that a lot of speakers here rose it as an issue, as a problem, and it was very interesting to see that people are trying to use AI. I think we have here, I can't see, but we have Hiv. She came all the way from Norway, and she has a very interesting concept, a business model and a concept of technology. How can you change the world of fishing and not doing the same way that it was done with nets and polluting ships until today? If someone wants to discuss with Hiv, she's here, I think, till the end of the day. And two last things is infrastructures. This is Dogon City, for those of you who didn't see it, a Japanese concept. How the city will look in the future, a floating city. Underneath the city you have data centers floating, being cooled by the oceans. And my favorite is the ocean spiral. Maybe the guys can give me a few insights later on the challenges and opportunities. But the ocean spiral is a concept that takes the difficulties we have to approach the deep sea, the bottom. It's like a rail, 4 kilometers deep. It's like, I think, 15 kilometers with the spiral if you want to go all the way down. And it's supposed to have a quick and direct access to a factory down on the sea level in order to help people live under sea and also do it in a sustainable way. Okay, enough for me. Oren, maybe you'll start?
Yes. Okay, thank you. Thank you, Sharon, and I'm honored to be here. So I would like to start by first telling you about the most interesting and fascinating place in Israel doing really marine science, which is the Leon Charney School of Marine Science at the University of Haifa. We see in there not only technology, but also okay, thank you. So the School of Marine Science is doing a lot of marine academic research in Israel in different fields, from marine technologies, which is the department I belong to, but not only that, also marine strategy and marine biology, including a lot of students and one of the leading institutions around the world doing marine science. And that's also a great opportunity to tell you that if you'll go to the booth outside to the university, you can see a lot about the new innovation program called Blue Spark to accelerate startups in marine environment, led by University of Haifa and other great partners. So that's a great opportunity if you would like to start a startup or you got a great idea and you're looking for funding, that's your way. So as I mentioned, our school is all around in Israel and doing different kind of startups, research, and basic science with marine robotics. When we are talking about AI, that's basically what we are talking. There is not much data around the world, especially in Israel, in the maritime environment. A lot of AI, buzzword, big data, data science. When you are starting to go deeper and deeper, you understand that the data is the key issue in the underwater and the mapping. So I will show you a bit of that, what we are doing in my lab named Sail, Swarm, and AI Lab. One of them is a very interesting one. We talked about underwater mapping and fisheries and how can we really see and understand what's going on in the deep water or generally underwater. So we developed a very interesting model with AI based on big data named sonar to image. You'll give me a sonar data and I'll give you in return an image data. I've never put a camera there, but still I will be able to show you what your camera would have seen if you would have such a one in there. But why is that important? It's important because for the infrastructures that we want to put down there, for the climate, for the serving this kind of capabilities, we would like to be able to really look on what's going on down there. So I'll show you really a few examples so you can understand what I'm talking about. So you can see in the next picture, in the bottom of it, you can see the source of the forward-looking sonar that we collected. In the middle, you can see real data from the camera that we put in the same location, which is correlated to the forward-looking sonar data. And in the first row, up in this picture, you can see what our model gave us based only from the forward-looking sonar data. So you can see that the difference between what our model produced and the real validated camera is not far. And you can see that also in the next example. So when you're talking about AI in the maritime underwater environment, that's what you're talking about. Capability to bring new capabilities based on current data, something that you cannot achieve on any other way. So Sharon, so I think that's what we are talking about when we are saying AI.
Thank you, Oren. Gil?
Hi, can you hear me? Yeah? So, you want me to comment on Oren's work or you want me to show my slides?
I think maybe you can share your slides and so people can understand your expertise, and after that we can have a chat.
Okay, so I made only 3 slides because I thought it's going to be like more of a talk show than a presentation. And so it might be a concise presentation, but I want to first present CAMERI, Coastal and Marine Engineering Research Institute, which is situated in the Technion, Israel Institute of Technology, and is owned partially by the Technion and by the Israeli Ports Company. We are a small research unit with marine and coastal engineering expertise. And as you can see in the slide, we have 4 main verticals that we operate in. The first one is the physical model. We have infrastructure for doing physical testing. We have wave pools and towing tank and a FLUM, which means that we can actually build scaled model and test them in oceanic condition, mostly in terms of waves, load, resistance, and so forth. The other thing we have is numerical simulation. I think that has been for the past years, that was the driver of CAMERI was mostly numerical simulations, where we work close with Israeli ports company on all their developments, making sure that we're not only up to standards with the performance of whatever they build, if it's a port or a jetty, but also the highest environmental standards. So our work is also being then shared with ecologists and people that can assess the associated effect of the change of the morphology on the environment. Then we have the data. We have actual data measuring systems in both Mediterranean and the Red Sea. We measure mostly waves and currents. And the last one is innovation. So being owned by Israeli Ports Company and the Technion, we serve as the innovation branch of IPC. And we work closely with IPC as Israeli Ports Company. And we work closely with them to fulfill innovation trajectories. Along these main pillars, we also have actual academic research, which can be both fundamental or applied. And this is concisely what we do. I'm heading the innovation and the academic research, and as Sharon introduced me earlier, I'm also a naval architect, so building ocean structure is what I've been doing the last 20 years. And nowadays, my main research focus is on urban development offshore, how to integrate the marine environment as an alternative for future development, which is done mostly from the technical perspective of it, how to make it happen, how we can do it safe and comfortable, but also from ecological point of view, how we do that without a trade-off, not being as bad as on land, but better, and perhaps even find a solution that will not only enhance our development, but also nature and biodiversity with the right decision that we're going to take in the future.
Okay, thank you, Gil. So I want to ask you, there are 2 main trends we are seeing. First of all is using sustainability at the ocean, and the second one is the deep tech. Both of you are collecting data, a lot of data, different kind of data, and I want to ask you, maybe share your vision. Oren, maybe you can share it regarding how do you see the swarm and AI being used at the ocean, and is it very far or is it happening nowadays? I know what I think, but it will be interesting to see what you think. And also Gil, from the perspective of floating structures and how humankind is going to move his balance from the land to the sea. How do you see it, and what are the main challenges?
For ocean monitoring, so to be able to work with swarm, which is distributed multi-agent system, we need to have some behavior rules. We need to have some very limited communication or maybe no communication, and we want the platform to be very resilient if some of them stop working. So ocean monitoring for sustainability is something which becomes very essential. We see that in other aspects for homeland security, but I'm not talking about that. We did a lot of work to develop with machine learning algorithms such as reinforcement learning tools for multi-agents of unmanned surface vehicles working together. One of the problems that we are dealing with is such kind of oil spills that we see around the world. We don't really know how to face that, so we built a model taking a lot of satellite data and building a model that can validate and predict the motion of the oil spill in the ocean. And for that, we developed a lot of machine learning algorithms for sustainability as a swarm that can work together. So this slide is to be the movies. So, you can see in here multi-agent surface vehicles that working together, predicting the oil spill location, and just track it and bounding the oil spills with the unique model that we predicted and developed in our lab in order to work with the swarm for sustainability and for climate challenges.
Thank you, Oren. Gil?
Going back to our question, how are we going to balance our life at sea? That's the question? Okay, so during my postdoc years in 2021 to 2023, we have wrote a proposal to the Dutch Ministry of Science promoting floating future. So how does the Netherlands going to deal with their issues, with land scarcity, population, everything that we have here in slightly more extreme way, how they're going to deal with it in the Netherlands. And we form some kind of supergroup that encompasses many types of scholars from policy and governance to ecology, naturally our part, which is more the technical part, and through kind of a wider scope we try to analyze all the aspects that we need to deal with when we are taking this challenge of moving offshore. The main issue with offshore living is waves. So in the Netherlands they have that only in the North Sea, because they have also inner water, which they can, and they are doing already floating structures. So Amsterdam already has a floating neighborhood, and there are other cities that adopting this idea. So floating is actually, it's quite easy in terms of building it, but it becomes more complicated when you do that in a dynamic ocean environment. It says time is up. Do I continue or? Yeah? 2 more minutes. 2 more minutes, okay. So the main thing that I'm dealing with in checking that future is to make sure that we sustain our floating structure in comfort and in safety. So it means that if you have a 100-year storm here in Israel, we have waves to up to 9 meters, and that's a lot of energy to deal with floating structure that can move in 6 degrees of freedom. So dealing with wave dissipation and energy dissipation and interaction of hydrodynamics to actually be able to sustain this type of energy in a comfortable way, the same comfortable that we feel on land. So that's the major thing I'm dealing with. And maybe we can just finish with this movie that I thought it would be nice to see how design of engineering structure can work well with ecology. What you see here is basically an anchoring system for our wave buoy in Eilat. So this is a measuring device that floats on the free surface, and 40 meters below, normally it has a 1 by 1 of cubic cement. And instead of that, we decided to develop a different approach together with Professor Ezri Tarazi from the Technion Design Tech Lab. They fabricated ceramic artificial reef, and within a year, in a depth of 40 meters, which is generally a Sahara, there is nothing there, it became a very vibrant, booming ecological environment. So this is something that can be integrated also in future urban development, and taking this as a consideration. This is a very successful project, and it just shows the potential that there is in the water. Just give it an infrastructure and life happens. That's great.
Okay, thank you very much. We need to wrap it up. Just a minute. Closing words. So first of all, we can take pictures without a camera underwater. This is what we understand from Oren, and we can also build structures that can be sustainable and help the ocean. And I just want to say that until now, we usually look at the ocean as a resource, and it's becoming an infrastructure. It's becoming a platform where we can build, we can transform data, we can transform energy, logistics, innovation, and the opportunities to scale it up. This is the reason why we are meeting today and to push sustainability and investment. So push it on, guys, for everyone who's dealing with it. This will be the next trend. Thank you very much.